Good afternoon, friends, and welcome back again to another maths class. Today we will be doing the differentiation using the first principle. As you all know that differentiation is a very important topic, and on that basis I have already given you some video uploads which you can see and go through it. And the another part of differentiation is the differentiation using the first principle. So this first principle, which is the logic to be used, that how differentiation is done, first principle. So by using limits, so by using the limits we will be seeing that how the differentiation is being solved. Okay, so for that you have to continue. So you have to follow the Parijat sir classes, and please, I would again request you to like, share and subscribe my channel, because it is this motivation which gives me to make more and more videos for you. Okay, so without wasting any time, let's go on to the differentiation using the first principle. So before starting the chapter, you have to first of all know certain important formulas regarding the limits. Okay, so first formula regarding the limit which you have to know is limit x tends to a, x to the power n minus a to the power n by x minus a is n a to the power n minus 1. X tends to a, x to the power n minus a to the power n by x minus a is actually n into a to the power n minus 1. Okay, second formula is limit x tends to 0 sin x by x is 1. X tends to 0 sin x by x is 1. Okay, so I will be taking the help of this maximum times. Similarly, limit x tends to 0 tan x by x is 1. I will take the help of this formula also. Similarly, limit x tends to 0 sin x inverse x by x is also 1. Sin inverse x by x. Similarly, limit x tends to 0 tan inverse x by x is also 1. This also we will take the help. Limit x tends to 0 a to the power x minus 1 by x is log e a. We will take the help of this formula. A to the power x minus 1 by x is log e a. Similarly, limit x tends to 0 log e 1 plus x by x. See, first of all you have to understand here that whatever is this angle, let me show you, please understand here, whatever is this angle at the bottom, it has to be same. Whatever is this angle at the bottom, it has to be same. If it is ax, you have to do ax here. Okay, similarly, see, whatever this angle, this at the bottom, it should be same. Whatever is this angle, this has to be same. Whatever is this power, this has to be same. Whatever is here, it has to be same. Okay, so similarly, if I use this formula, see, please see here, limit x tends to 0 log e 1 plus x by x is 1. But here limit x tends to 0 log a 1 plus x by x. 1 plus x by x is log e, log ae, log ae. Here if it is log e, okay, please remember here this 1 you can write it as log e, and if it is this you have to write log ae. Now log ee is 1, and that is why they are using 1. But log AE is not 1. Okay, so if it is log A, you have to write log AE. If it is log E, you have to write log EE. In this way you have to remember. So these are the very important formulas which you have to go through and memorize, because until and unless you don't know these formulas, the first principle numericals you cannot do. Please remember it. The first principle numericals you will only be able to do if you know these formulas. And please take care of the angles. Okay, so I'll show you today how to use this particular concept of the limits. Clear? So let's see. Y equal to e to the power x square. So we have to find the differentiation of this using the first principle. Okay, we will use the first principle. So using the first principle, so please note here how to find dy by dx. This is the formula of the first principle. This is the formula of the first principle. This is what you will be using to solve the first principle. Dy by dx is actually limit x tends to 0 fx plus h by minus fx by h. This is the actual formula which you will be using it to solve the limits, to solve the differentiation using the first principle. Okay, this is that formula. Please note it here. Limit h tends to 0 fx plus h minus fx by h. Now fx is your original equation. Fx is your original equation. That means here fx is the y equation. Fx is the y. So let's see here. So limit h tends to 0. In place of fx, this y is actually what? This y is the fx. So if fx is e to the power x square, fx plus h will be e to the power x plus h whole square. Okay, in place of x I will put x plus h minus fx. So this is our fx by h. Clear? Now see how to write this formula. X plus h whole square is opened up. Now we will take e to the power x square common. So this comes here minus 1. So please note now that there is a formula limit x tends to 0 e to the power x minus 1 by x is 1. This formula we will be using it here. So please, as you can see that here there is no h, so this will go out. So this has gone out and the limit will be applicable to this part. Limit will be applicable to only this part. But as I told you, this is looking as e to the power x. This is looking like e to the power x minus 1. So I told you at the bottom, whatever is e to the power this, at the bottom it has to be same. So it is 2h plus h square, 2hx plus h square. So bottom also it has to be 2hx plus h square. So this is the adjustment I had to made extra. This is the, because the angle has to be same. This has to be same at the bottom. This has to be same at the bottom. Okay, so now when we apply the limit to this part, please watch here. When we apply the limit to this part, see it is looking like limit h tends to 0 e to the power x minus 1 by x. Isn't it looking like? It is looking like that. So its whole value will become 1. And this is the adjustment. So I have to apply the limit here also, because it contains h. So I have to apply the limit here also. So this was already out and this value is 1. So this is 1. And now applying h tends to 0. So this will become 0. So it is 2x. So the differentiation of this is 2x e to the power x square. Differentiation is 2x into e to the power x square. So we have taken the help of this formula, and this is the answer of this differentiation using the first principle. Okay, let us see the next sum. So please watch here one thing, that is, in this sum we have to differentiate this using the first principle. Okay, so as you know, the first principle differentiation is written like this: limit f h tends to 0 f x plus h tends to 0 f x plus h. So friends, as you can see that this is the first principle, limit h tends to 0 f x plus h minus fx, fx plus h minus fx. As you can see, 1 minute, there's some problem here. Okay, so this is our first principles formula, limit h tends to 0 fx plus h minus fx by h. So this is our fx, this is our fx. So fx plus h means instead of x I have to put x plus h, and this is our fx. So taking 2 to the e to the power 2x common, so this becomes this. Now this does not have any h, so it is a constant, it will go out, so it will go out. Okay, so what is remaining is I will apply the limit in this part. In this part I will apply the limit, but here see, the angle is e to the power 2h, so here should be a 2h at the bottom, so this is 2h, so we have adjusted the 2 by into 2. Okay, and this also goes out, so this part becomes 1. Applying the limit formula, this part becomes 1, because limit h tends to 0 e to the power h minus 1 by h should give me 1. So this is the same thing, so the angle here is same, 2h, so it should give me 1. So 2 into 1 into e to the power 2x, so 2 e to the power 2x, that is our formula, that is the answer of this sum. Next is, if I apply, this is the fx, this is the fx, the function is e to the power root x. So now applying dy by dx, so see, this is the first principle we are applying, this is the first principle we are applying here. So in place of x I will put x plus h, so it becomes e to the power root over x plus h minus fx, so this is our fx by h. Now what we have to do here is, please watch one thing, that is, in order to take e to the power root x common outside, see, this power has to be made e to the power root over x plus h minus root x, because if I multiply with e to the power root x this much, it will give me e to the power root x plus h minus 1. Okay, because e to the power root x is common, minus 1. Now this whole angle becomes this, so we have to write at the bottom this, because using this concept, e to the power h by minus 1 by h, so the power and the denominator has to be same. So here the power is this much, here the power is this much, this is the power of e, so the at the bottom we have to write this much, same thing. And now we have to adjust this, so you have to multiply. Okay, and this h which was there, this h which was there, it is now being written here, this h which was there is now here. Okay, so now this whole formula becomes 1, this whole thing becomes 1, because it is coming under a formula. Which formula? This formula. Okay, so this becomes 1, and now applying the limit on this part. So what we are doing is that we are rationalizing the numerator, so we are multiplying with the opposite sign, up and down. So the up becomes a minus b into a plus b, which is a square minus b square. Okay, so this cuts, and this also will now cut. So it is 1 by this, and now putting h tends to 0 in this part, so it becomes root x plus root x, which is 2 root x. So answer is this. This is the answer of the differentiation of y e to the power root x, y e to the power root x. Clear? Okay friends, so let's see the next sum. So the next sum says we have to differentiate e to the y equal to e to the power sine x. So this is our fx, and now applying the first principle, this is how we write the first principle. This is how we write the first principle, which is limit h tends to 0, fx plus h, means instead of that x I will write x plus h minus fx. So this is our fx by h. Okay, so now again taking e to the power sine x common, so we have to subtract the power here. So please see here, the power here now becomes this. If I take e to the power sine x common, so the power of the first one will become this. Okay, and now here what we have to do, that since this is the power of the e, we have to write the same thing at the bottom. We have to write the same thing at the bottom. Okay, we have to write the same thing at the bottom. And since we have written this, so we have to adjust it by writing here. We have to adjust it by writing here. And now applying the limits. So this is, this part is looking, this part is our formula. This part belongs to the formula. What formula? Limit h tends to 0 e to the power h minus 1 by h, which gives me 1. So see, this power and this has to be same. So that's why we made this power and this same. So this whole thing becomes 1. This whole thing becomes 1. And now applying the limit on this part. Limit on this part. Okay, so it is sine a minus sine b. Sine a minus sine b is 2 cos a plus b by 2. Sine a minus sine b, the formula is 2 cos a plus b by 2 sine a minus b by 2. So this is our a and this is our b. So putting this, we get this formula. And now applying the limit here. So first we will apply the limit on the cos part, and then we will apply the limit on the sine part. So we know limit h tends to 0, cos h is 1, and limit h tends to 0, sine h by h is 1. So let us now take the limit. So this is the cos part and this is the sine part. So the angle of the sine is h by 2. So we have to write the same angle at the bottom. So here is the h, we have taken the help, and here is the 2 which has come down. So we don't have to adjust anything with this part. We don't have to adjust anything with this part. So this becomes 1, this becomes 1, and this is e to the power sine x. Okay, so here, sorry, this does not become 1. So putting h tends to 0, this becomes cos 2x by 2, which is cos x. So this, and then e to the power sine x. So this is the answer of this sum. So let us see the next sum. So the next sum says our fx is log sine x. This is our fx, this is our fx, which is log sine x. So applying the first principle, we will write limit h tends to 0, fx plus h, fx plus h, that means instead of x I will put x plus h minus fx by h. So this is what we have applied here. Now log a minus log b, we already know log a minus log b is log a by b. So applying this concept, so log, this is our a and this is our b, we put it here. Now we know that the formula of the log is, so let us check the formula of the log. So please watch here, this is the formula of the log. It is log, limit x tends to 0, log 1 plus x by x is 1, log 1 plus x by x is 1. This is the formula, log 1 plus angle by this, should these two should be same, should be 1. Okay, so using these, now let us go ahead and see what is our sum. Okay, so applying here, so I want to make log 1 plus, so this is my, please watch here, please watch here, this is my, I have done what, 1 plus this minus this, 1 plus this minus this, because I have to bring log 1 plus h by h, which will give me 1. So I have to bring log 1 plus, that's why, since I have to bring 1 plus, so I wrote 1 plus and then adjusted with a minus 1. So now this, taking LCM, we got this, and sin a minus sin b is 2 cos a plus b by 2 sin a plus a minus b by 2. Okay, by sin x, this we got. So please watch here that when I am applying, so I have to write log 1 plus h by h. So here is our h, 1 plus h, here is our h, here is our h, log 1 plus h. Please note here, this is my 1 plus h by h, by h. That means we wrote the same value, and since we wrote this, so we have to adjust it by multiplying it. Clear? You have to adjust it by multiplying it. So now this whole thing gives me, 1. This is log 1 plus x by x. This is log 1 plus, this is my x by x. So 1 plus x by x, this is giving me 1. Okay, so now I have to apply the limit on this part. So let's see here. So since this gives me 1, so please watch here, I have to apply the limit on this part. Clear? So I have to apply the limit on this part, and this part separately, and I have got an 1 by h as a help with me. So now first of all, this whole thing gives me 1, as we have already done. This whole thing, please watch here, this whole thing gives me 1 because it is log 1 plus x by x. It gives me 1. And now applying the limit on this part, so limit on the cos part, limit on the sine part, and please watch one thing, and limit at the bottom. So here is, and this is a constant, it does not have any h, so it can go out basically. And please watch here, sine, we know limit h tends to 0, sine x by x, so here is that angle h by 2, h by 2. So we need at the bottom we need an h by 2, we need h by 2, so we have to adjust h by 2, but we don't need to adjust because already we have got 1 by h as a help, already we have got a 1 by h as a help, and this 2 as a help. this 2 as a help, which goes down. Here is that 2 and here is that 1 by h. So we don't have to adjust anything. So this will give me 1. Okay, and here putting 0, we get cos x. So basically we get, first from the log we get 1, and then we get cos x, and then in the limit h tends to 0, sin h by 2 by h by 2 gives you 1 by sin x. So basically it is cot x. So this is the answer with the first principle. Using first principle we got this as the answer. Clear? So let's see few more sums. So now, as you see, this is my fx. This is my fx. Clear? And I have to find the differentiation of this using first principle. So as you know that the first principle formula is this. This is the first principle's formula. That means in place of x, I will put x plus h. Instead of x, I will put x plus h. Instead of this x and this x, I will put x plus h. So here I put, in place of x, I put x plus h, and in place of tan inverse x, I put x plus h. Now minus fx, as you know that fx is my original equation. This is minus fx by h. Clear? So now taking x common from both, I can write tan inverse x plus h minus tan inverse x plus h tan inverse x by h. Okay, so now this is tan inverse a minus tan inverse b. Please watch here. Tan inverse a minus tan inverse b, formula is tan inverse a minus b by 1 plus ab. So that is what we have used. This is tan inverse a minus b by 1 plus ab. Okay, so this is what we have used it. So now from here x and x will cut, so it remains, and this is the thing. And we already know that in the limit there is a formula. In the limit there is a formula. Limit h tends to 0, tan inverse h by h is actually 1. So what is the angle with tan inverse here? It is h by this. This is the angle with tan inverse. This is the angle with tan inverse. Okay, this is the angle with the tan inverse. So let's see how to now write it.